All right, so we're talking about inequalities. Inequalities. If you guys remember this symbol, how are you guys trying to do it?
Is it less?
Is it less or is it greater?
It's greater.
Let's put a number to make this make sense, right? If I put 6 here, what number could I put here?
2.
5, 2, any number, right? And now we can see 6 is greater than 5, right? You always eat up the alligator eats up the bigger number. Yes. So this is greater than. So that makes this. Anyway, what does that make this one?
Greater than or equal
There you
to.
go, greater than or equal to. Of course, that makes this less than, and that makes this less than or equal to. Any of you going to football games tonight? If you see me, I'll be there with just me and my 2 little kids. Say hi. So here's the thing, and it kind of goes back to what Serrano was saying about graphing here. There is something that's different between a graph that has a less than symbol and something that has a less than or equal to symbol. And it really depends on ink. Sounds weird. Which one of those symbols, this one or this one, does it take more ink to draw? I know it's a silly question, right? It takes more ink to draw this line, right? So that actually means that it takes more ink to draw that line versus this line. In other words, when you have simply greater than or less than, it is a dashed line. And I'm going to do that over here too. It's a dashed line because it does not include the values on that line. Whereas, if you have greater than or equal to, it's a good solid line. And I say the word ink because I actually got taught from a student that last year. They said, wait a minute, doesn't it make more sense if it takes more ink to draw the symbol than it takes more ink to draw the line? Like, yeah, actually that's pretty smart. So we're going to use that. The solution to these problems, the solution is very simple. It is the quote unquote double shaded region. Now we're doing all this to kind of prepare ourselves for the first real unit of Algebra 2, which is on something called linear programming. Then we're going to have multi-shaded regions. We're going to have like 3 or 4 of these inequalities that you'll have to graph all at the same time on one graph. And then the one that's layered, 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 that's kind of the one that's the answer. In other words, all inequalities are graph line and shade. That's what I'm getting at. You guys kind of remember how that works? So in other words, I'm not going to do it up here yet, but I'm just going to show you on the board what I mean. It's this, I graph a line based on y equals mx plus b. That's nothing new. And then if this point is part of the solution, then I shade this way. If it's not part of the solution, I shade away. Okay? I'm going to talk about what I mean as we're going through this. Let's graph our first one, number 1 here. Okay? And it's easier than you think. How do I graph, forget that that's even a less than or equal to symbol. How would I graph the line y equals negative 3/2 x plus 5? Where would I start that line? At plus 5 on the y-axis. Remember, this is y, this is x, so y. So I go up 1, 2, 3, 4, 5, and put a dot. And what does negative 3/2 mean I have to do? Go down 3 and, where do we always go? Right 2. Okay, so let's do that from that point. Down 1, 2, 3, right 2, put a dot. Now again, I've always said you only need 2. For my sake, I like to always do 3 just to get it more accurate. Now here's the thing, based on what I said up above, is this going to be a dashed line or a solid line?
Solid.
Why?
Because it takes more ink to draw the symbol.
Boom, I like it. We're using that already. Alright, so let's do a nice solid line here. And the accuracy of this is not quite as important as it was in the previous section when we were doing like points of intersection and stuff like that. But I've got that. Now, if you have a different writing utensil, like a pencil and a pen, or you would like to maybe borrow a different color from me, over there I have some like colored pencils, colored pens, stuff like that. You can use something of mine if you'd like, pencil, pen, red, blue, doesn't matter, blue, black, doesn't matter to me. I'm going to use red and black. Okay. Now, the way the shading works is we are going to test a point. And 98% of the time, you can test the point 0, 0. Where is 0, 0 on your graph? Take your pencil, put your pencil right on 0, 0 on your graph. Right now. Everybody put your pencil on 0, 0. Remember what the other word for that is called?
The origin.
The origin, good, okay. Now the origin has the point value of 0, 0, right? Let's put this up here. Origin equals 0, 0, right? So if I test that point and it gives me a true statement, this will make sense as we go through a few examples, but if it gives me a true statement, then we shade, then that 0, 0, that's in our solution and we shade towards it. If we test that point and it gives me a false statement, in other words, is 0 greater than 4? The answer is no. 0 is not greater than 4. So then I do not shade that way. I would shade away from 0, 0. Here's what I mean. Let's look at this first example. I'm going to plug in this point right here, 0, 0, where I just had you put your pencil or pen. That means I'm going to plug 0 for y and 0 for x right here. Let me write it over here, and I want you to do this too. I'm plugging in 0 there, and I'm plugging in 0 there. When I plug in 0 for y, of course I just get 0. Less than or equal to, what's anything times 0? 0. And then I can just add 5, right? So can I just put 5 instead of 0 plus 5? Kind of means the same thing, right? Is that a true statement? Say it in your head a second. Is 0 less than or equal to 5?
Yeah.
Yes. 0 is strictly less than, right? It's not equal to. But it's less than 5. Everybody okay with that? So that means that this point, 0, 0, is in the solution for that line. So we shade our line towards 0, 0. If that was a false statement, let's say the sign was the other way around. If I had 0 is greater than 5, then that means that would be a false statement, which means this would not be in the solution. So from the line, I would shade away from 0, 0. So you're always, always, always either shading towards 0, 0 or away from 0, 0.
Can you kind of look at the signs to figure out where you shade?
Yes, but sometimes, and I see what you're saying, because greater than you think you go up, right?
Yeah.
Sometimes when the line, and I think you're going to see it on number 3, it's a little harder to see because the line is like this. And it's like, wait, is it up this way or is it up that way? You know what I mean?
Mm-hmm.
Sometimes it's harder to see that, but this is always, always works, never goes wrong, okay? So, 0, 0, I plug it in, I get 0 is less than 5. Okay, again, so that means that this point works. So I want to shade my graph towards it. Don't do it too dark, do it kind of light, because we're going to have a second one here in just a second. Okay. So all of those points to the left of the line, down towards 0, 0, work. In fact, I could plug in any point I want. I could plug in 0, 3 and see if that works. 3 is less than 5, that still works, so that means 0, 3 is also a solution. How about 2, 0? Well, if I plug in 0 for the y and 2 for the other one, I get 0 is less than, negative 3 plus 5 is 2, and 0 is less than 2. Yeah, that works too, so that point is also put a solution. All of these points in the shaded region would work for that to be a correct answer, okay? None of them up here would work though. All right, so let's look at the second line. Second line, where do I start?
-3.
Negative 3 on the y-axis. And I go, anybody?
You go up 1.
Up 1,
Over 2.
over,
Right.
right 2, right, yes, right. Okay, I'm gonna do it again, and that would actually give me my point of intersection, which to be honest with you, in this section, I don't care about. Okay, I'm not even worried about my point of intersection. So let's do it, wait a minute. Dash this out. Dashed, because it's not have an equal sign, it's less ink. This is a dash line, okay? So, let me put my dash line. Connect my dots. Because again, I'm not including the points on that line. And then, what did I say I do to check to see which way to shade? What did we just do in the previous problem?
Plug in the origin.
Plug in the origin. So plug in 0, 0. So again, I'm plugging 0 in for y and plugging 0 in for x. So 0 here and 0 here gives me 0 is greater than, half times 0 of course is 0, negative 3. Remember, minus signs are negatives. Is that true? Is 0 greater than negative 3? Yes, right? So, matter of fact, I should have done this before. I should have put a check there and a check there. If it's not, I'm going to put an X, okay? But if I put a check here, and I know 0, 0, so what does that mean? Can anybody tell me what that meant? Which way do I shade?
Towards the origin.
Towards the origin, right? I love the way you said that, towards the origin. So this line goes up like this, okay? So, go ahead and shade that up. Now the thing is, can you see on your own paper what the double shaded region is? Can you see it? Can you see it on my paper? Kind of hard to see, isn't it? So that's where you got to do one of two things. You either got to darken it in, or maybe use a highlighter or something so that I don't have to guess, wait, where did they mean the double shaded region is? So I'm going to just kind of do this kind of thing with my highlighter. And that's my solution. That's it, I'm done. Graph and shade, make sure I know which is the double shaded region. Teja, you look like you had a question. Is it from the very beginning? Let's do one more. I think if you see one more, maybe you'll see. Okay. Let's do number 2. I'm going to talk about number 4, but I want to do number 2 together. The first line, I think we can all graph it. Let's go ahead and do it right now. Let's go up to 4. Wait a minute, then what do I do? Down 2, right?
Over 1.
Over 1. Why, Ms. Brabant?
Because it's 2 over 1.
That's right, because if I put that as a number, it's 2 over 1. So I go down 2, always go right, down 2, always go right. This, now based on what David's saying, it's got more ink, so let's fill it in as a straight line, as a solid line, excuse me. And I don't want to say it, I want you to try it. Plug in what I've been saying to plug in. See if you can figure out which way to shade. 10 seconds. Plug in your 0, 0. See if you can figure out which way to shade, up or down. Which way? Am I shading to the left of the line or to the right of the line? To the left? Why? It worked. When I plug in 0, 0, I get 0 is less than or equal to 4, because again, this would kind of go away with the 0. And yes, that's true, so indeed, we shade left. And this is the kind of thing that I was talking about earlier. This would be a hard one, like, do I shade up? Which way is up? You know what I mean? Like, if we plug in 0, 0, we can't get it wrong, right? So again, I plug in 0, 0, it works, so this is in the solution, I have to shade towards 0, 0. How do I graph the other one? Do you remember how to graph x equals -3? From when we did it on that 6-1 worksheet?
You have to take it from the other side.
Oh, that's, okay, yeah. Straight, is it straight across? Is it straight up and down?
Straight and down.
Why?
Because it's not going across. I don't know how to explain.
You have to cross that.
Like,
There you go. It has to go through, it has to go across the x-axis. X has to go through the x, right? So let's, again, dash line, be careful. Dash line at x equals -3, and it goes through the x. So at x equals -3, I'm going to put a nice dash line here. And this is going to be pretty easy to shade, because it says x is greater than -3. Where on your graph are the values greater than -3? To the left or to the right? To the right, right? That's just normal thinking about number sense. So let's shade that to the right. All of this stuff gets shaded. So again, I can't necessarily see it as well, so either darken it or highlight it. Or use a different color, whatever you gotta do to make sure I understand what it is. You know what, I'd even be okay with that. If you don't wanna darken it on the inside, you can just outline it so I see you know what it is. Don't make me guess. What do you think? Think it cleared it up a little? Maybe we should try one on our own. You guys do number 3. We'll do 4 together in a minute. You could probably even graph one of those in 4, but I don't know if you know what that other one's in 4. If you do, go ahead and try 4 too, but let's get 3 done first. If you have a question, stop me as I'm walking around.